Hello everyone. I'm going to talk about a study on NIOS2 instruction set. This is my term project report for Advanced Computer Architecture class. My name is Min Zhang, and here's today's agenda. At first, I'm going to talk about the project objective, followed by a brief introduction to NIOS2 processor. And then I will compare what is RISC and what is CISC. Then the instruction types of NIOS2 is presented, followed by a 5-stage pipeline. Finally, I'm going to present the project design model and the conclusions. The project objective. This project is to implement a 32-bit 5-stage pipeline NIOS2 processor instruction set architecture for the computation of dot product and dot product of two vectors, and also to compute a factorial. The instructions. Introduction to NIOS2 processor. NIOS2 is a 32-bit embedded processor architecture designed specifically for the Altero family of FPGAs. It is a soft-core architecture. This architecture is implemented entirely in the programmable logic and memory blocks of our FPGAs. The soft-core nature of the NIOS2 processor lets the system designer specify and generate a customized NIOS2 code to meet the special requirements. The NIOS2 processor has a RISC architecture. RISC stands for Reduced Instruction Set Computer. Its logic operation and arithmetic are performed on operands in general-purpose register. In the following slides, I'm going to compare what is RISC and compare what's the difference between RISC and CISC. Well, RISC stands for Reduced Instruction Set Computer, and CISC stands for Complex Instruction Set Computer. Most personal computers use CPU based on CISC architecture. For example, the Intel and AMD CPU are based on CISC architecture. Well, for CISC architecture emphasis more on hardware, while RISC emphasis more on software. In RISC architecture, it is register to register. But in CISC architecture, it is memory to memory when you use load and store instructions. In CISC architecture, the code size is usually small compared with RISC architecture. The code size is usually large. Well, our processor is based on RISC architecture. There are basically 3 instruction types in the NIOS2 processor. The first is I-type, as shown in this figure, the first row. The 5-bit field of A to B are used to specify general-purpose register. A 16-bit field immediate value provides can be side-extended to provide a 32 operand. And then R-type instruction. In R-type instructions, the 5-bit fields A, B, and C are used to specify general-purpose register, and the 11-bit field OPX is used to extend the opcode. And then the last one is the J-type instruction. A 26-bit field immediate contains an unsigned immediate value. This format is used only in the call instruction. Well, to achieve a higher speed and a better throughput, the NIOS2 processor architecture is pipelined as 5-stage, which includes instruction fetch, instruction decode, instruction execute, memory access, and write back. During the instruction fetch stage, a 32-bit instruction was fetched from the cache. The program counter feeds into the PC predictor, which then sends the program counter to the instruction cache to read the current instruction. At the same time, the PC predictor predicts the address of the next instruction by increase the PC by 4. During the decode stage, what type of the fetch instruction is identified, and it is passed to the execute stage, where the required operation is performed. In the execute stage, the computation occurs. Typically, this stage consists of an ALU and also a bit shifter. Then, in the memory stage, the computed address is used to either load data back to a register from the location at the memory by a memory read, or data is written by memory write. Finally, at write-back stage, both single-cycle and two-cycle instructions write their result into the register file. In this project, we are going to calculate the dot product of two vectors. At first, we are going to calculate the dot product. The dot product is as shown in this program. The two vectors are stored in memory location addressed by vector A and vector B, respectively. The number of elements is stored in location N. I think you can see this. No, it's not clear. And the vector A is set to 5, 3, minus 6. 19, 8, and 12. This is the value given in the same value given in the NIOS2 handbook. And it is noticed that assign a negative value is different with assign a positive value. You have to use the 2's complement for the negative value. And then this is a waveform of the simulation. Screen is a little off, but you can see at the red arrow points to the value of vector A, and the blue arrow points to the value of vector B. And then the final result stores at after the yellow arrow, but it's not appeared in the screen. And next, we are going to calculate the factorial. Well, the basic idea to achieve a factorial calculation is to call the subroutine call. The previous value is stored in the stack memory, and then when later the value is fetched to calculate the result. You can see the previous value is stored there and then fetched from here. Well, we can see without pipeline structure, the processor takes 5 cycles to execute a single instruction, but with pipeline, each instruction is executed in one cycle. So the higher throughput and higher speed is achieved by employing the pipeline structure. Thank you.